Hi all, this presentation is about carrots. During the presentation, I'll be moving this little vegetable around, and you can see all my keyboard inputs in the bottom left corner. In other editors, a carrot looks like this I-beam or an underscore, and a lot of the time it's blinking. This presentation is also about visual editors, so for context, I want to show you this spectrum of visual editors, starting on the left here with the tried and true versatile traditional code editor. In this editor, you're editing text and you're moving your carrot around to navigate that text. Next, we have a structural editor. In this editor, it looks like text, but you're actually editing something like an AST, and that can make the controls feel pretty unfamiliar and unintuitive, but you can put some interesting things in your code, like this matrix. Next, we have this code or text editor that lets you embed and create custom interactive editors and put them in your code. In this particular slide, we have some code that defines a red-black tree balancing algorithm. Next, we have a structural editor that lets you embed and create custom interactive editors into your code. Here you can see a color picker embedded in some code, a table and a slider embedded in some code, and a plot of some grades embedded in some code. These two editors beautifully blend text and visual editing. Next, we have Scratch blocks, which is actually quite similar to the structural editor, except that you're moving blocks around and you're thinking spatially about how you're rearranging your program. And finally, on the right, we have a representative from the wondrous and underexplored region of spatial programming. In this programming language, you define some rules spatially and using colors, and then your program plays out in a spatial and color-based way. So you're never thinking about text or ASTs or anything like that in this programming language. It's totally visual and spatial. So I really love this entire spectrum, but I'm in particular interested in building a bridge between text programming and visual programming. So I've been working on a side project, which is a hybrid text visual editor called Polytope. But in Polytope, we can't navigate visual editors without using our mouse. And I'll show you what I mean. I've switched over to Polytope here. And I have a graph editor in my code and a music editor. And let's try to edit one of the nodes in my graph editor using just my keyboard. I'll press right a few times on my keyboard. Oh, I'm on the other side of the graph. I'll press left a few times and I'm on the other side of the graph again. There's no way for me to get into the nodes of the graph and edit them. So I have to move my mouse, click on one of them, and use my keyboard, and then click outside. And down here, we have a slightly more robust example of a music notation editor where I can navigate in and out of it. But there's some weird things, like if I press up or down, I just stay in the editor, where I might expect to go to the line below or the line above outside of the editor. And likewise, if I go down here and then press up, I just go to after the music editor or before the music editor. And this is because right now my navigation is implemented in an index-based way. So I know in Polytope I want to have Caret navigation for all my editors, but what should visual Caret navigation be? First of all, it should feel text editory, which means that it should strongly utilize the intuition users have coming from a text editor. And it should be a natural extension of text editor controls. If we come up with a scheme for visual Caret navigation and we apply it to text, then we should get back normal text editor controls. And if we apply it to visual editors, it should feel intuitive and like an extension of text editor controls. It should also be automatic. So it should work for any visual editor. So users can create editors without thinking about Caret navigation. In other words, the Caret navigation should be based on visual properties and it should be independent of the data model of the user's editors. This is important for accessibility so that we can guarantee that all editors have Caret navigation. Finally, it should be composable, which means that controls should be seamless and identical in between and in and out of diverse editors. Navigating around a document full of diverse editors should just feel like you're using one control scheme, and you shouldn't feel boundaries between editors where you have to think about switching control schemes. So the idea behind all of this is to unite visual programming and text programming with some common controls. With all this in mind, I looked all around for a Caret navigation algorithm, but upon research, none of them had what I wanted for Polytope. Here's what I looked at and researched while working on a solution to this problem in Polytope. I looked at the W3C spatial navigation spec for web browsers. You can use this in your web browser if you enable a flag, and it allows you to navigate around web pages using keyboard controls that feel spatial and intuitive. I looked at an awesome Stack Overflow thread called four-way navigation algorithm. There's a great GitHub repo called spatial keyboard navigation. Netflix has a blog post on four-way Caret navigation because on a TV, users just have access to a remote with 4 directional controls. So Netflix wants to make their UIs work automatically on TVs. And I also looked at rich text editors, but the problem with these is that they're closed source, so I don't know what they're doing. And it's also unclear if their methods can be applied to arbitrary user-created editors or if they just work for the editors or the components that are available in these rich text editors. What makes text editors so text editory? I want to answer this question from a spatial and visual perspective so that I can apply my answer to visual and spatial editors. To consider this, let's look at this example code snippet down here. I can navigate this code snippet just like a normal text editor. And firstly, this text has a predefined set of places where the caret can go, which I call caret sinks, and I visualize it here. And these caret sinks are purely spatial data. Each of them are an x and y coordinate of the top of the caret sink and then length of how far the caret sink extends down. Or you can use a different representation like an x and y coordinate of the top of the caret sink and an x and y coordinate of the bottom of the caret sink. But the idea is just that it's spatial data. Now that we're thinking in terms of caret sinks, here's the main idea. In a text editor, caret sinks are partitioned into lines. These lines are vertically ordered from top to bottom. And inside each line, caret sinks are ordered strictly from left to right. Once we've partitioned caret sinks into lines, it's easy to define the actions of the 4 arrow keys on the caret. Pressing left goes to the previous caret sink in the current line, unless you're at the beginning of a line, or the first caret sink in a line, then you go to the last caret sink of the previous line. Pressing right goes to the next caret sync in the line, or if you're at the end of the line, it goes to the first caret sync in the next line. Pressing up goes to the closest caret sync in the line above to define it spatially instead of in a column-based way. And pressing down goes to the closest caret sync in the line below. And we can see how that works for differently sized lines. The main idea is that caret syncs are partitioned into lines. These lines are vertically ordered, and with caret syncs partitioned into vertically ordered lines, it's easy to define the actions of the arrow keys. This idea is what differentiates this work from the prior art, and we can use this idea to extend text editor Caret Navigation to visual editors. I'll briefly describe a way to put partition caret syncs into lines. Start by putting every caret sync in a line by itself. Then, until you can't anymore, repeat finding the two closest lines that don't vertically overlap and merge those two lines, as long as merging doesn't cause that line, the new merged line, to intersect with any of the existing lines. Note that your choice of distance function matters. If you want horizontal lines, you should choose a distance function that is biased towards things that are horizontally close. Now I'll just go through some extra examples, and then I'll show off something extra you can add to this idea. So here's some visual editors with their caret syncs, and we can group these into lines in the same way. And with that, we can use the method I just described to add caret navigation. I just navigate around a bit. Now, you might notice something a bit strange, that if you navigate over here, what's after the S is the n equals 1 line, and pressing up here goes to n equals 1, where you might expect it to go directly to here. And that's because the n equals 1 is on a line on its own. Now we'll show off a way you can group together caret syncs so you don't get these stray lines that seem to be part of this summation notation or this diagram. So you can group together caret syncs that should be grouped with other caret syncs. And that's the idea of nested caret syncs. The idea of nested caret syncs is that lines are made up of caret syncs or caret syncs containing other caret syncs. And if you navigate to a caret sync that contains other caret syncs, then it delegates to the caret syncs inside of it. Here I can navigate within the summation notation with line wrapping now. And if I go to this line and I press down, it doesn't go to n equals 1, it goes to this, what feels like the next line. And it's important to note that although the representation is nested and hierarchical, if we turn off the visualization, to the user, it shouldn't feel hierarchical. It should just feel like you're navigating to the intuitively right place based off the direction you're pressing. Thanks for watching. I hope to make some more information and maybe some code about this Caret stuff available at some point. So you can follow along at elliot.website/editor.